Example. Use the table below to answer parts A through D. Given is the population of 3 towns rounded to the nearest thousand. So my towns are P, Q, and S, and I have their populations over various years. So the years are 2000, 2001, 2002, 2003, 2004, and 2005. I'd like to find the average rate of change for each of these towns over the entire interval. So between 2000 and 2005. So to do that, I'm going to take the change in the population divided by the change in the time. So for town P, I'm going to call that delta P over delta T. And again, I'm doing that between 2000 and 2005. So if I look at town P, you'll notice that the 2005 population was 3,000. No, it wasn't. 30,000. And the population in year 2000 was 10,000. And then the difference in the years would be 2005 minus 2000. And if I do the math out, that's going to give me 20 divided by 5, or 4. Now again, I want to put units on. So my population units are people in thousands. So I'm going to just go 1,000 people divided by my units of T, which are years. So what's happening is the population is changing by approximately 4,000 people per year. Let's do the same for town Q. That would be delta Q over delta T. And you'll notice in this case, all of the towns had the same starting population and the same ending population. So all of the math will be exactly the same. So again, I'm going to get 4,000 people per year. Again, town S, delta S over delta T. And again, it's the same arithmetic. So again, I'm going to get 4,000 people per year. So all of these have the same average rate of change over the entire interval. But if we look at the remainder of the table, we will notice that they don't have exactly the same populations in each year. So as we look at the rest of the problem, let's see how that comes into play. So part B, find the average rate of change of town P between 2001 and 2004. So if I do town P between 2001 and 2004, there's 2001, there's 2004. I'm going to be doing delta P over delta T. In 2004, the P population was 26. In 2001, it was 14. And then let's just see, 2004 minus 2001 gives me 12 over 3. Hey, it gives me 4 again. So I'm going to have, again, 4,000 people per year. In fact, if we look at population P, you will notice that population P actually does increase by 4,000 people every year. It goes 10, 14, 18, 22, 26, and 30. So it increases by that 4,000 every year, where the others don't. So the question that gets asked is each town's population behaving the same? And of course the answer is no. Right? Population P is going up by 4 each year. If we look at population Q, you'll notice it goes up by fewer each year. It goes up by 7 the first year, 6 the second year, 4 the third year, 2 the fourth year, and then only 1 that last year. And if we look at population S, it actually increases slowly and then increases more rapidly. It increases by 2 the first year, and then 3, and then 4, and then 5, and then 6. So it increases more rapidly. Part D is plot the graph, and I actually did this for you. You'll notice in population P, the increase is what you would probably call linear. Population Q, that population has an increasing appearance still, but it starts to increase more slowly, what we'll call later on concave down. And then S actually starts to increase more rapidly. So although they all start in the same spot and end in the same spot, what they do in between is different from one function to the other.